Solving systems by elimination. So again, a system is just two or more equations that work together, and I want the coordinate point that makes both equations true. Now, elimination will work best when both equations are in standard form. So if you see that you have x's and y's on the same side, that's when elimination is going to be the simplest method of solving to use. So general steps for elimination. Step 1, both equations must be in standard form. So if I look at example 1, well, both of these are in standard form. The x's are on the same side as the y's. So in step 2 is find a variable with the coefficients that add up to 0. So if I look and if I try to add -3 plus -4, well, that's -7. But if I add -5 plus 5, that's a 0. So that means that my y's are eventually going to add up to 0, which means we don't need them. So I'm going to, step 3, add my equations together. So -3x minus 4x makes -7x, -5y plus 5y makes 0y, and then -7 plus 14 makes 7. So here, if I have 0 times any number, well, that just makes it a 0. So all I really have is -7x plus 0 equals 7. But then if I take -7x and add 0, well, that's just going to give me -7x. So really, the y's do what we say canceled out. They added up to 0, which is unnecessary information. Now solve this for x is a simple division. X is going to be equal to -1. So there's one of my solutions. That's part of it. Now that I have the x, the next step is finding the y. So take either one of these equations, whichever one looks simpler to you. I like the top one because it has smaller numbers. So I'm going to rewrite the top equation. -3x minus 5y equals -7. So what I'm going to do is I'm going to take my x value that I found a minute ago and substitute it in for the x. So -3 times x is now -1 minus 5y equals -7. And I'm going to solve this equation for y to get the other half of my solution. So this makes 3 minus 5y equals -7. Subtract 3 from both sides. -5y equals -10. Divide by -5. And you end up with y is equal to 2. So your final solution is a coordinate point. The x value of -1 and the y value of 2. Number 2, 4x plus 3y equals 6, -4x minus 12y equals 12. So again, find variables that add up to be 0. So if you look at our x's, 4 plus a -4, well, that's 0. So I can go ahead and move on to step 2, which is adding my equations together. So 4 plus a -4 makes 0x, 3 plus -12 makes -9y, and then 6 plus 12 makes 18. 0 times anything is going to be a 0, so all we really have is -9y equals 18. And then solving for y is a simple division. Y is equal to -2. Finding your x means I'm going to take -2 as a y and substitute it into one of the original equations. For me, that top equation looks simpler because there's smaller numbers and less negatives. So now we're going to take y equals -2 and plug it in where y is. So 4x plus 3 times -2 equals 6. And then solve this guy down for x. 4x minus 6 equals 6. Add 6 to both sides. 4x equals 12. And then divide by 4, so x is equal to 3. Write your final solution always as a coordinate point. So it's 3 first because it's the x, comma y of -2. Example 3. So we have 6x plus 5y equals 19, -2x minus 3y equals -5. So if we look at our equations here, try to see if we have something that adds up to 0. So we have 6 plus a -2, well, that makes 4. That's not 0. 5 plus -3, that's 2. That's not 0. So now we're going to have to kind of manipulate this a little bit. So I'm going to try to multiply by something to make my numbers add to 0. So if I talk about 6's and 2's, I don't like fractions. Fractions make life difficult. So instead of trying to make a 6 into a 2 or a 5 into a 3, go from the smaller numbers to the higher numbers. So I can make a 2 into a 6 fairly easily. All I have to do is multiply by 3. Now, if I try 3's and 5's, well, I can't make a 3 into a 5 by multiplying by a whole number. So I'm going to have to hold off on those. So I need to make these guys add up to 0. That means I want both of them to be 6's, one positive and one negative. Well, luckily, I already have positive and negative. So all I need to do is make the 2 into a 6. So I'm going to have to multiply the entire equation by 3 on both sides, left and right. So that first equation doesn't change. 6x plus 5y equals 19. But that second equation, I'm going to multiply everything by a 3. So 3 times negative 2x makes negative 6x. 3 times negative 3y makes negative 9y equals, and then 3 times negative 5 makes negative 15. Now if I look, I have my x's, and 6 plus a negative 6 does in fact make 0 like I was planning. So now I can go ahead and add these up and follow the same steps as I did for the first two examples. 6 plus negative 6 makes 0x, 5 minus 9y makes negative 4y, and then 19 minus 15 makes 4. Then 0x is just a 0, so we can ignore that. So negative 4y equals 4, and then finding y is a simple division. 4 divided by negative 4 is equal to negative 1. So now we have half of our solution. So to find the other half, the x value, we need to plug this negative 1 somewhere into the original equations. And I always use the originals because they're smaller numbers than anything you may have manipulated on the step 1. So I'm going to use that top equation because it has less negatives. Negatives can sometimes be difficult. So now I'm going to take this negative 1, substitute it in for y, and I'm going to solve for x. So 6x plus 5 times y is now a negative 1 equals 19. And I'm going to solve for x. 5 times negative 1 makes negative 5 equals 19. Add 5 to both sides. 6x equals 24. And divide by 6. X is equal to 4. So my full solution is a coordinate point, the x value of 4, comma the y value of negative 1. Example 4, 2x plus y equals 12, negative 3x plus y equals negative 18. So with elimination, step 1 is always finding variables that add to 0. So 2 plus negative 3, well that's going to be negative 1. And 1 plus 1 for the y's makes 2. So nothing adds to 0 yet, so I'm going to have to multiply by something to make it add to be a 0. Now, when you add to 0, you need the same number of coefficients, just the opposite sign. So let's look at our x's. So I have 2 and a 3. I do have a positive and a negative, but I would have to try to make 2 and 3 the same number. Well, the only multiple that 2 and 3 share is a 6. So that means I would have to multiply the top by some number and the bottom by a number. That's a lot of multiplying. Let's look at the y's. So for the y's, I see they both have 1's in the front. The only problem, because they're already the same number, is that they're both positive. So I need 1 as a positive 1 and 1 as a negative 1. So the way that you change a sign without changing the number is you're going to multiply by a negative 1. It doesn't matter which equation you do this to, but I'm going to choose to do it to the bottom equation. So I'm going to multiply that bottom on both sides by negative 1. So my top equation is not changing. 2x plus y equals 12. But my bottom equation is going to be multiplied by a negative 1. So negative 1 times negative 3x is a positive 3x. Negative 1 times 1y is a negative 1y equals negative 1 times negative 18 is a positive 18. So now let's look. I was hoping that my y's would add to 0, and in this case, a positive 1 plus a negative 1 does in fact make 0. So now I'm set up to add these equations together. 2x plus 3x makes 5x, 1y plus a negative 1y makes 0y, 12 plus 18 makes 30. And then 0y is just 0, so I can get rid of that. So 5x equals 30. So now we solve for x by doing a division of 5. X is equal to 6. Now that we have x, we're going to go into the original equations and solve for y. that top equation looks simpler because it has more positives than negatives. So now I'm going to take my x value of 6 and substitute it into the top equation. So 2 times x is now a 6 plus y equals 12. 2 times 6 makes 12 plus y equals 12. Subtract 12 from both sides, so we have y equals 12 minus 12 makes a 0. Normally we don't need to write them, but because there's nothing else on this side of the equation, I need this 0 as a placeholder. This is not one of those special solutions, as I still have a variable left to solve for. This is just saying that y is equal to the number 0. That's perfectly fine. So my solution here is 6, 0. Example 5. 5x plus 4y equals negative 14. 3x plus 6y equals 6. So let's check and see if something adds to 0. 5 plus 3 makes an 8, so that's not 0. 4 plus 6 makes 10, and that's not a 0. So I'm going to have to multiply to make something be a 0. Well, if I look, try smallest number to high number, there's no number I can multiply to 3 to make a 5, and there's no number I can multiply 4 to make a 6. So that means I'm going to have to multiply both equations this time. So let's think about what's easier to get rid of. What we're going to talk about is lowest common multiples. So multiples are like when you skip count, like 2, 4, 6, 8, 10. Those are multiples. So if I look at the multiples of 5, I have 5, 10, 15, 20, 25, and so on. 3, I have 3, 6, 9, 12, 15. Well, look, 15 is the lowest common multiple between the two of them. Now let's look at 4s and 6s. 4, I have 4, 8, 12, 16, 20, 24, 28, and so on. If I look at my 6s, I have 6, 12, 18, 24, and look, there's my lowest common multiple for 6 and 4. Now, we don't like large numbers, so which one has the smaller common multiple? Well, that would be the 5 and the 3. So that means I'm going to focus on getting rid of these x's. I'm going to leave y's as y's. I'm going to focus on getting rid of the x's. So that means I need them both to be 15s, one positive and one negative. So let's focus on the 5. 5 times what will give me a 15? Well, that would be a 3. Then, if I look at the 3 on the bottom, 3 times what gives me 15? Well, that would be a 5. Now, when I multiply these, remember I need the same number, but opposite sign. When I do 3 times 5, I get a positive 15. If I do 5 times 3, I still get a positive 15. So that means I need to make one of these negative. I'll just make the 3 negative because it's smaller. Now when you multiply, negative 3 times 5x makes negative 15x. 5 times 3x makes a positive 15x, which is what I needed. So let's continue multiplying because you have to multiply the entire equation. So negative 3 times 4y makes negative 12y equals negative 3 times negative 14 makes a positive 42. Now for the bottom. 5 times 6y makes a positive 30y. 5 times 6 makes a positive 30. Now that my x's are going to add to 0, I can add my two equations together. Negative 15x plus 15x makes 0x. Negative 12 plus 30 makes a positive 18y. And then 42 plus 30 makes 72. 0x is just 0, so we can ignore that. So all we really have is 18y equals 72. Solve for y by dividing. So y is equal to 4. Now that we have half of our answer, go back to your very original equation. So before you did all the multiplying, see which one looks easier for you to use. I think the bottom one may be easier because the 3, 6, and 6 are much smaller numbers to work with. So I'm going to use that bottom equation. It doesn't matter which one you substitute that y value into. So I'm going to change this y value with the 4. So I'm going to have 3x plus 6 times y is now a 4 equal to 6, and I'm going to solve for x. 6 times 4 makes 24. Subtract 24 from both sides, and we get 3x equals negative 18. Divide by 3, and we have x is equal to negative 6. So your final answer is putting these two into a coordinate point. So -6 for the x, comma 4 for the y. Example 6, 2x plus 8y equals 6, 8x plus 32y equals 24. So if I look quickly, nothing adds to 0. 2 plus 8 makes 10, 8 plus 32 makes 40. But I do know that I can multiply by a single number and make the x's canceled. So if I try to make a 2 into an 8, I need to multiply by a 4, but I need the same number, which the 4 will achieve, but I need opposite signs. So I need this 4 to be a -4. So multiply this in, so the top equation becomes -8x, -4 times 8 makes -32y, -4 times 6 makes -24. And the bottom equation doesn't change because we didn't have to multiply the bottom. Now that I know my x's will add to 0, I'm going to go ahead and add these together. So -8x plus 8x makes 0x, -32y plus 32y also makes 0y, and then -24 plus 24 also makes a 0. Again, I need this as a placeholder because there's nothing left on this side of the equation. Well, 0 times anything is a 0, plus 0 times anything is also a 0, and 0 plus 0 makes, well, 0. So we have that weird situation when all variables are canceling. So that means I have to take a look at what's left over. Well, 0 equals 0. That's true. 0 does equal itself. So when we have no variables but a true statement, our solution is that we have infinitely many solutions. Any number will work for this equation. All variables canceled, we were left with a true statement, 0 equals 0, 2 equals 2, 4 equals 4, anything like that, and we have infinitely many solutions. Example 7, -18x plus 6y equals 24, -3x plus y equals 2. So I need to multiply by something to make these add to 0, because right now, -18 plus a -3 is -21, and 6 plus 1 makes 7. So you could do either the x's or the y's, but I'm going to do the y's because I know this is a 1. And 1s are easy to make into anything. So I'm going to multiply this bottom equation. I need to make a 1 into a 6. So I'm going to have to multiply both sides by 6. But I see that these are both positives, so I need to multiply it by a -6 to make them opposite signs. So the top equation is not going to change. But the bottom equation, -6 times -3x makes a positive 18x, -6 times 1y makes -6y, and then 2 times -6 makes -12. This is ready to add together. So -18x plus 18x makes 0x, 6y plus -6y makes 0y, 24 plus -12 makes 12. On the left, 0 times anything is going to be a 0. 0 times anything is also 0, equals 12, and 0 plus 0 makes 0 equals 12. So we have something similar. Again, all variables canceled out. So we look at what's left. 0 equals 12. Well, that's false, because 0 is not the same number as 12. So since we have no variables left and we have a false statement left over, our answer is no solution. There is no x value or y value that will make both equations true.